Good morning, students. In this video, I will be discussing on TCP/IP protocol suite. Before watching this video, I recommend you to watch my previous video, that is OSI model. The link for the video is available in description box. So please watch the complete video. Then you can watch this video so that you can easily understand the TCP/IP protocols, suites, and also the functionalities of each layer. But one point to keep in mind, the functionalities of the layers is almost same for OSI layers as well as TCP/IP layers. So as I already told in the previous video, that OSI is a reference model and this TCP/IP is been derived from that OSI model. So here mainly I am concentrating on which are basic protocols available in each layer of TCP/IP model. Okay. As I told you, TCP/IP protocol suite is made up of 5 layers. One second, I will just take the pen. That is physical, data link, internet, transport, and application. So what happened here? In OSI model, we have seen there is a physical layer, there is a data link layer, and there is a network layer. Instead of network layer, we named it as internet layer in TCP/IP model. Then there is a transport layer, and lastly, we have the top 3 layers, that is session, presentation, and application. Those 3 are clubbed together and they have named it as application layer. And even here also, this physical and data link, if you refer few textbooks, you will come to know that these 2 layers are clubbed together and they have named it as host to host layer, or we can call it as interface layers. So strictly speaking, there are only 4 layers if you combine these 2. So for your understanding, I am not combining these 2. I am telling separately that there are 5 layers, that is physical, data link, internet, transport, and application. Okay. So as I already told you in the OSI model also, the first 4 layers, that is physical, data link, internet, and transport, will provide physical standards in the physical layer, network interfaces in the network layer, internetworking again the network layer, and lastly we have few transport functions. So these are all functionalities we have already seen in the OSI model. And as I told you, the 3 topmost layers, that is session, presentation, and application in the OSI model, they have clubbed together and they have named it as a single application layer in the TCP/IP model. Okay. So this is what your comparison between TCP and OSI model. Here you can see clearly physical and data link. They have named it as host to network layer, or separately physical and data link. And in the network layer, I have named it as internet layer. And this is transport, session, presentation, and application. These 3 have clubbed together and they have named it as application layer. So these are the 5 layers in TCP/IP model: physical, data link, internet, transport, and application. But here you can see few protocols I have mentioned. Like in application, we have SMTP, FTP, HTTP, DNS, SNMP, Telnet, and etc. we have. But however, I am just telling the functionalities of each protocol, basic protocol. And in transport layer, we have standard protocols like TCP, UDP, and SCTP. And in network layer, we have IP, ARP, RARP, ICMP, and IGMP. And in physical and data link layers, we don't have specific protocols. So it can be used for defining all the underlying networks. So this part we will study in the upcoming videos in depth. Okay, all the functionalities of data link layer. Now let us see about each and every layer, which are the protocols we have and what is its functionalities. Coming to functions of physical layer, same thing what I told in the OSI model, same repeats here. It helps in carrying the individual bits from one node to the another node. It helps in fixing the transmission media. whether it is coaxial cable or fiber optic cable or twisted pair cable or any wireless media, and helps in signal transmission and also helps in converting bits to signals, means digital to analog and vice versa. Okay. Coming to data link layer, the main functionalities are it is responsible to make the frames. It helps in error handling and also it helps in checking the physical address. As I already told you, this physical address is also known as MAC address or Ethernet address, link address, which is of 48 bits. So I am not going in depth here. Please watch my previous video, which is there in the subscription box to get more details about it. And the network layer, so it is helps in creating the network using some shortest path. And here it is also helpful in finding the logical address, that is IP address, and also it helps in routing. Okay, so this is very important part. Which are the what you call that protocols we have, standard protocols we have in network layer. So first one is internet protocol, that is IP. Next we have address resolution protocol, ARP. So ARP is responsible for finding the MAC address whenever we have an IP address. Okay. Reverse address resolution protocol, RARP. Mainly this protocol helps in diskless systems. Means whenever we don't have any IP address of a system, then this RARP will help you in mapping or getting the IP address from the MAC address. It's temporary IP address you can get. ICMP, Internet Control Message Protocol. This protocol mainly helps in uh, message control. Means the data which you are transmitting, if it lost or if something happens wrong, why that is happened. So we have a number of messages. So it will give the exact reason why that error has been occurred. So more information about this ICMP we will see in the upcoming videos. And IGMP, Internet Group Message Protocol, so which is responsible for multicasting the data. So sending information to a group of systems. So coming to transport layer, so the functionalities are same. It helps in end-to-end communication. It helps in process-to-process delivery. That means finding the exact port number or peer-to-peer communication. All those things transport layer will help you. So the three standard protocols are UDP, that is user datagram protocol, which is connectionless, and TCP, that is transmission control protocol, which is connection oriented protocol. And we have n number of UDP protocols and TCP protocols. We will see more information regarding this during my next video on Wireshark tools. Okay. Next we have SCTP, that is stream control transmission protocol, which is responsible for controlling the flow of data, with stream of data. Lastly, we have an application layer. As we already know that application layer is almost equal the same functionalities of the OSA model, because n number of services the application layer is providing. So since it is combining all the three layers of the OSA model, like it is combining session layer, which helps in dialog control. It helps in presentation layer, that is, it helps in encryption, translation, and also compression of data, and also the main services provided by the network, that is application services. So few protocols I have mentioned here. One is HTTP, that is Hypertext Transmission Protocol. And next we have what is known as SMTP, that is Simple Mail Transmission Protocol, which helps in sending the emails. So in depth about this protocol we will see in the upcoming videos, where we have like a POP, Post Office Protocol, POP3, as well as IMAP, Internet Mapping Tools. All this we will study in the upcoming videos. Next we have FTP, that is File Transfer Protocol, which is helps in sending the files. And we have DNS, that is Domain Name Systems, which helps in getting the IP address from the domain name. So like this, we have a number of what we call that protocols. So all this simulation of all these protocols, all UDP protocols as well as TCP protocols, we will see in the Wireshark tool. There I will explain how to simulate all the protocols, and in depth we will see uh, each and every protocol, how it operates, what is its functionality, and all those things in a Wireshark tool. Okay, thanks for watching and subscribe for more videos. Bye.